Welcome to this video. In this video, I will just describe some information in question and answer format from a research paper. It's about radar-based target detection, where deep learning is applied. I think a study on radar-based detection based on deep neural networks. Okay, so this is the research paper. So a study on radar target detection based on deep neural networks. So what this research paper has done, it used deep neural network, as said before, for radar-based target detection. And also it has compared this deep neural network-based target detection with CFAR, constant false alarm rate-based target detection. I think for deep neural network, it used the technology called CNN, convolutional neural network. It's fundamentally an image classification approach in deep neural network. So that same approach is applied to radar signals for classifying objects. Objects means cars, pedestrians, airplanes. Okay, just examples of targets, not necessarily this research paper has discussed about them. Okay, so yeah, CNN convolutional neural networks, and it is just some sort of filtering, and the constant false alarm rate. It is just some Doppler, radar Doppler. However, how can this CNN be applied on these radars? I think CNN works on image, so radar Doppler spectrum that can also be seen as an image. So that's why CNN can be applied on this radar Doppler spectrum to identify objects. So different objects will create different spectra. That is one thing. And also sometimes setting the important point can be whether this is an object or a false alarm. This classification, I think this is this should be a very important for sure. Okay, I didn't read on it yet. I've just looks like that is highly likely, right? First of all, you have to identify whether this is a false alarm or this is a real target. Then it comes down to what object is this. So yeah, the application might work better if you can identify what object is this. And sometimes if you can identify the object, you can you'll be able to say, okay, what is the motion model it usually uses, or what is the velocity ranges or acceleration ranges this type of object uses. So probably the direction or the natural characteristics, depending on that, I think your application can work better. So first object, whether it's a real target, real object, and then what type of object is this. Anyway, this paper is primarily about target detection based on CNN, and that will be compared with CFAR. What this research paper has found is CNN works better than the constant false alarm rate when signal to noise ratio is large. And I believe, yeah, usually probability of detection is found to be higher on CNN-based target detection than CFAR. I think what it means, I think the probability of detection for CFAR and probability detection of CNN, I think CNN PD was found higher. I think at this point, I think the probability of false alarm rate or those things, those are kept the same for both approaches. They actually did not use actual radar data. They actually have used simulation data, and then they applied their CNN algorithm. Okay, and CNN deep neural network, you know that it's a neural network. Yes, kind of brain neurons connected. And deep neural networks means there will be multiple layers of network, and each layer will have multiple neurons anyway. So yeah, they can be connected in different way. They can feed the data forward. They can feed the data backward and do some sort of processing. Okay, there will be some input and there will be some output. So input layer, it will take some input, and those in between that and layer, they will do some mathematical computation to understand what is in there, and the feature extraction, what are the different features are there, and depending on the other side, it will just do the classification. And if there is just only two objects, let's say, if we want to know that whether it is a real object or it's a false alarm, then the classification has only two output. So in that case, I think it will be using SigMoid, and if it is multiple classifications, multiple object classifications, then it will be using softmax. I think as this research paper is trying to identify different objects, they used softmax on the other side. And like CNN, they also used filter. I think what in original image classification, what it does, I think it uses some filter, means that the smaller area that scans over the images, small by small, one by one, and it tries to learn the features within the smaller areas and try to learn all the edges, and depending on those, eventually it is able to identify the images, whether it's a dog or cat, food or not. Yeah, those type of things. A similar concept will be used here on the radar Doppler spectrum. Okay, I think so far I have given an overview of the research paper, I mean the work. So I think I will now answer some information. I think I'll give some information or answer some question based on that research paper. Okay, I think I don't have much to write down here. I think I can just answer those questions. So, is target detection an important problem? Target detection, I think it's about whether target exists or not. Well, just it's about detection, whether it exists or not. Then probably classification can be important, what object it is. And then, yeah, in applications for sure, in many of the applications for sure, the path or tracking of those targets for sure objects will be important. Yeah, definitely target detection an important problem for radar-based applications. And also it can be important in applications like self-driving cars. I think self-driving car, it uses LiDAR, that is one sort of radar or similar. So yeah, different object like pedestrian, traffic lights, or other cars, all those bicycles. So all those are different objects. So classification can help in self-driving car applications for sure. So yeah, I already have mentioned this. Why is target detection shown as a classification problem? So classification problem because the targets can be cars or pedestrians, aeroplanes. I do not want to say that it can be a missile as well. Anyway, so yeah, the detection will have to classify them. So that's why it's a classification problem. And yeah, I think the targets we are expecting that they will be on the same environment. That's why we need to classify them. I think that our target areas, I think our region where we are trying to do this detection and classification, yeah, we are expecting that, okay, here the targets will be here or they will be come and go, but yeah, within that region. Okay. Yep, on another note, whether it's an object or false alarm. So that is also a classification problem. So what is the popular strategy in detecting target? Popular strategy in detecting targets. I think in relation to AI. So deep neural network can be the one. I think neural network, it does not say whether it's a deep or single layer. Deep neural network, it just says that between input layer and output layer, there will be multiple layers of multiple processing layers. So sometimes for very simple applications, you can just have one single processing layer, input layer, one single processing layer, and the output layer. But for DNN, no, I think there will be multiple processing layers. So what approach of deep neural network is used for target detection? I believe I already have mentioned that. It's CNN, convolutional neural network. So what are the some of the traditional target detection approaches? Traditional target detection approaches like filter match or matched filtering. I think what it does, it matches known signals with the unknown signals and try to identify what sort of object it is. Depending on the Doppler or spectrum or radar echo. So yeah, it compares those with some known signals. Okay, from this type of object, these are the Doppler effect or echo, those kind of things. Yeah. Okay. Yeah, matched filter. I think a little bit mixed up with Doppler and matched filter. I think matched filter, you can see it more simply that it matches known signals with the unknown signals to identify or to detect what that unknown signal is. And Doppler processing, Doppler, it usually means that the echo of the radar signal. I think radar goes, I think if you think about the active radar, right, it will be transmitting some signals and it will be receiving some echoes from the target object. So this is the Doppler thing. And then after the Doppler, I think from the analyzing the echo, it will identify what kind of object, sorry, yeah, what kind of object is this. So different object is supposed to send different type of signals. I think the properties will be different. So yeah. And sometimes hypothesis testing that is also used traditionally for target detection. So yeah, one of the classical example for hypothesis testing is the false alarm rate. Yeah, I think in this paper, false alarm rate that is also studied and compared with this CNN. And one of the important example that CFR usually use, Newman-Pearson rule. I think what it tells, Newman-Pearson rule, that maximum likelihood ratio, that is the most important for the classification. Anyway, it will come. Now I want to move to the next question. How does the hypothesis testing work in CIFAR? Well, let's say, what is hypothesis anyway? Hypothesis testing anyway. You form some hypothesis. Let's see that average investment income is 6% over a long term, at least for index investing. So this is a hypothesis. Now you will test against the data or using some different experiments. So that's the hypothesis testing. Okay, as talking about hypothesis testing, yes, you found some hypothesis and then you test it. And null hypothesis, that's one form of hypothesis testing. So what does the null hypothesis say? I think you assume that that your assumption is true, and then you test it whether it's true or not. If the null hypothesis is rejected, I think there can be one another alternate hypothesis. So when the null hypothesis is rejected, the alternate hypothesis will be used. The null hypothesis, it will use some confidence level, like 99% confidence level or 95%, and there will be some critical values that okay, if the founding is below that thing, so it will be rejected, those kind of things. Okay, I might come back to it and say a little bit more. Okay, so how does the constant false alarm rate work in target detection using hypothesis testing? So the procedure is the CIFAR will test the hypothesis for each of the cell individually. I think cell, you for sure you know that. I think the radar has a target region. You divide it into multiple cells in multiple regions. So at one time, you can just scan one particular cell and test the hypothesis, and then go to the next cell and test the hypothesis. I think whether the target can be detected or not, or what kind of target detection is there. And sometimes you also use some N out of M. I think if N detection is true out of M, that you declare, okay, you really detected a target. I think I'll come back to it. I think in terms of when you are tracking some targets, this similar concept is there. If I think the Mn can be reversed there. If out of N, you find M in the same track, same, I think, let's see. In terms of tracking, so you get the measurements and you try to associate those measurements into different paths. So out of N detections or N measurements, if you see that M of them are associate for a particular track, then you confirm, okay, this is a real track. It's not a false alarm, or it's, okay. Anyway, I can, it's not tentative, it's a confirm. That's a different thing. I'm going into different direction. So yeah, I think as you're telling how hypothesis testing is used in CIFAR. So it does it, hypothesis testing, cell by cell. And it does cell by cell because the target echo, object echo, it can span over multiple cells, especially when the resolution of radar is high. Okay, exact text from my note, because the echo of radar signals can appear in multiple cells when the resolution of radar is high. I think in terms of how the radar scans each cell or entire region, it can depend on the type of radar or type of application, and whether you are searching or you are tracking Yeah, so yeah, I think it can differ. I think whatever I say, depending on the current context, but there will be other things as well. So what is the concept of hypothesis? Coming back to this, form a hypothesis, test it against null hypothesis. So hypothesis testing is about testing against a null hypothesis. What is null hypothesis? You form a hypothesis, test various propositions about a data. Example, test that the mean age of Canadian population is 53. So the hypothesis is the mean age of Canadian population is 53. Now, I think null hypothesis, it's actually a multiple step process. So one of the first step is assume that the hypothesis that you just formed is true and test it. And then you will have something, yeah, it can be some ways to identify whether this null hypothesis is true or false. If it is true, then you got the true, but if it is false, then you actually will have another alternate hypothesis that will become accepted, and null hypothesis will be rejected. And yeah, there are some significance level, critical value. Those are some other concepts in relation to null hypothesis testing. Null hypothesis testing actually is a multi-step process. I might say a little bit at the end of this discussion what are the different steps. I think it's around five different steps. So Newman-Pearson method, I think so far we saw that the constant false alarm rate, they use the hypothesis testing, and one of the example is Newman-Pearson method. So what does this Newman-Pearson does? So it tells that likelihood ratio test is the most powerful test. So it will be doing that for cell by cell and try to understand that whether target detection is success or not. It's a classical solution for simple hypothesis testing. We're talking about Newman-Pearson. That is a simple hypothesis testing. Okay, that is the classical solution for simple hypothesis testing. So what are the different types of deep neural network? And different types of deep neural network. One can be RNN, recurrent neural network. So deep recurrent neural network. I think they use some sort of memory. I think in general, the basic neural network, it does not have any memory or storage. It does not do anything with that. And fit for the recurrent neural network, it fits usually in the backward. And deep feed forward neural network, okay, output of one layer is fed to the next layer, and for sure there will be multiple hidden layer, multiple layer in between input and output. So it feeds the forward. And convolutional neural network, I think as I told before, I think it uses some sort of filters, small filters, and it scans over the area of interest or over the image. If it is image classification, then I think it will be using many filters, and for each of those scan, it will try to understand the features for that region, and it will scan, keep scanning, and over those findings, it will be eventually classify that. I think in our example, it will classify what kind of target it is, and in its classification, yeah, what kind of image it is dog or cat or those kind of things. So which DNN is used in this paper for target detection? You already know, I have told many times, convolutional neural network. True or false, CNN has achieved great success in classification. Convolutional neural network has achieved great success in classification. Yes, for sure. That's what we told so far. Is CNN one-stage architecture? No, CNN is not one-stage architecture. It's not just that you give it and immediately you process it and can get the output. It's not like that. Okay, I think this single stage architecture, it probably is better that the exact information or exact definition, you find it and then match what I said. Yeah, it may be the same thing. It might differ slightly, but this CNN, it's not a one-stage architecture. It's actually a multi-stage architecture. So it will be in one stage, it will be extracting feature, and then in the next stage, it will be doing the classification based on the extracted feature. So how does different DNN architectures differ? Yeah, I think how many stage, okay, stage, probably I don't say stage here. It can be how many layers are there, singular, multiple, and whether they feed data forward or whether they feed data backward, and the number of nodes in each layer, and also by the depth of the network, one or multiple. What do the two layers of a CNN model do? So first layer, feature extraction. Second layer, multi-layer perception classifier. You can just say it's a classifier. However, it is stating multi-layer. So on the classification side, it will also have multiple layers. And the feature extraction side, for sure, it will have multiple layers. So it will be using convolutions filters to learn those features. Give some examples where DNN are used in radar applications. I think it is telling to see something, to name some applications, the radar-based applications where DNNs are used. Yeah, it's not exactly classification. It's not exactly asking for classification. It's just DNN for radar applications. I think some of the applications that the research paper has mentioned, I will just say the name of those applications. So one thing is waveform detection or waveform classifications. So recognize radar waveform. That is one application. And classifications of micro UAV, unmanned aerial vehicles. So DNN is also applied to micro Doppler classifications, yeah, eco classifications, micro level. So also automatic target recognition. That's where also DNN technologies are used. Okay. Yeah, so the question is there, what is the type of radar? Okay, I think you can look for it. I think the example is pulse coherent radar system, single beam radar, narrow beam radar, multiple beam. Okay, anyway, I might have made some of the name right now, but you can check. So what are the layers in generic radar-based detections? What are the layers in generic radar-based detections? Okay, I think the question actually is, I think, what are the different methods? It's not layers. I think I wrote it, layers is the wrong word here. So what are the different traditional target detection approaches used for radar applications? So matched filter, I think we already talked about, I think using known signals to detect to classify the unknown signals. Doppler processing, it will be using the echo signal. By processing echoes, it will identify those. And cipher detector, constant false alarm rate. Then we saw that it will use some hypothesis testing, just Newman Pearson. That is the maximum. I think that is likelihood ratio is the best measure kind of things. Yeah, as it uses. What is the input for constant false alarm rate detector? Range Doppler spectrum. Range Doppler spectrum. What is the coincidence detection process? So coincidence detection process, it's not just single detection. It will be comprehensively determine if a target is there or not. It's not just for one detection and decide. It will be using comprehensively and using multiple detections and using some other logic to find out the detection of objects or detection of targets. That's what it is called. That's called coincidence detection. What is a classical coincidence detection method? It's a binary integration. So how does binary integration work? Okay, I will say something exactly from the research paper. Okay, so binary integration work. If the detection is repeated m times for a given range Doppler cell, the binary integration process requires that a target be detected at least n times in m decisions before being accepted as a valid target detection. Yeah, I think I told it before. So out of m, there should be n number of successful detections, then we can consider it as a detection. Yeah, m and n, just parameter values you give to the application. Yeah, I think there might have some parameter tuning approaches for sheer parameter tuning might work. I think sometimes this understanding the parameters, what are the exact configuration of the parameters that can give the better outcome, that is also sometimes a research topic, and also those things are done in machine learning or deep learning a lot. Yeah, understanding parameters, or that is the perfect configuration of the parameters. Yeah, simulations can find out those good values for those parameters. So can target detection be considered as an ATR application? Yes, target detection can be considered an automatic target recognition. Yeah, it's automatic. And why the authors are using DNNs for target detections? Because DNN in general work well for automatic target recognition. That's why they are also applying DNN for target detection. Yeah, I think we just told that target detection is an ATR application, and DNNs has worked well for ATR applications. Why not apply DNN for target detection? In another case, we studied that why CNN and image classification approach is used for target detection or target classification, because the radar Doppler spectrum that can be seen as an image, so we can apply CNN on this spectrum image, right? So what is the primary use of CNN? Image classification primarily. Why CNN and image classification technique can be used for radar-based detection? Are not they very different things? No, I think still it can be used. Yeah, they can be very different things, but still they can be used, because the range Doppler spectrum that can be considered as an image. what is the decision that CNN takes here? CNN classifies the image as target, present, or absent. How does CNN differ from CIFAR? CIFAR detects the image cell by cell. And yeah, I think cell by cell it will work. For the, that's the CIFAR. For the CNN, it will be using sliding window. Sliding window, it does not mean that it has to be exactly the cell size, radar cell, it's different to the radar cell. And using that sliding window, yeah, it will be sliding over the spectrum image by a fixed window. I think it just does filtering and scanning one areas of the images and then feature extraction, those kind of things. So yeah, it is using, CNN is using sliding window approach, and CIFAR is using cell by cell. So how big should the sliding window be in CNN? CNN, the sliding window, it has to be larger than the target echoes. So how does CNN work for image classification, such as JPEG or PNG images? Yeah, same sliding window. It scans, learns features, learns edges, and decide what sort of object it is. What does CNN do? The coincidence detection. Okay, it's not what does, actually when this coincidence detection will be done by CNN. I think by this time we know that coincidence detection, it is not just one single detection. It will be comprehensive detection in multiple steps. And so we saw that N out of M approach. So that's what it will be using. That's what CNN will use for this coincidence detection. What does CNN use as input in this processing? CNN, what does it use? Yeah, it is using this Doppler spectrum image. So yeah, that should be the input. Data after each Doppler processing. Okay, it's a little bit more than that. I think it's only the Doppler spectrum. It will do some processing, and then CNN will use that as an input. So what is Doppler anyway? Yeah, it's just the echo, right? How many layers CNN uses in this paper? So it will be using almost 8 layers. I think the feature extraction, it will have some layers. On the feature, I think the classification, that will be using some more layers. Looks like I need to take a break. Too much talk. So we just told that how many layers CNN has. CNN has 8 different layers. Some are on the feature extraction, some are on the some are on the classification sides. So what are the different 8 layers? Okay, at this moment I will not say what is for feature extraction and what is for classification, just what are the different 8 layers. 2 convolutional layers, 2 ReLU layers, 2 max pooling layers, and 2 fully connected layers. So how many parts are there and what do they do? Yeah, I think we already discussed 2 parts, extraction and classifications. So what are the layers that does the feature extraction? It is the convolutional layer and max pooling layer. So convolutional layer, there are 2 of them, and max pooling layer, there are 2 of them. So it looks like 50% of them are on the feature extraction side. And what are the layers for the classification? 2 fully connected layers. Those are on the classification side. What are the, let's say, So we are telling 8, right? To convolutional, to ReLU, to max pooling, to fully connected. Yep. Okay, I think we already told this one. Okay, what are the layers that do the classification to fully connected layers at the end? I think what happens is, I think in deep neural network, each, okay, how, let's say next layer, it will be using the previous layer. And if you just consider there are multiple hidden units or multiple neurons, and whether you connect everything to everyone, if you connect everything to everyone, that's the fully connected. And if you don't connect everything to everything, I think each processing unit you can think, then that's not fully connected. In fully connected, each processing unit, they will be connected to each other. I think at the last end, now the classifications, they will be using this fully connected. I think in the feature extraction, it does not have to be fully connected. I think after all those feature extraction, at the final step, we are using fully connected layers for the actual classification. What are the configuration of the CNN layers used? Okay, yeah, it will be pretty long. Configuration of the CNN layers. It is telling for each of the layer what are the different configurations used. Input, a range, Doppler, spectrum, sample. So this input size that will be determined by the size of the sliding window. So input, it will have multiple layers. Layers count, it will depend on the M count. So in general, each layer, a range, Doppler, spectrum, sample. Okay, I think it's referring to the input layer. And first convolutional layer, it will have 32 filters, and each filter will be 5 by 5, and for all M scans, there will be M by 5 by 5 filters. And second convolutional layers, I think in the 8 layers, we saw that there are 2 convolutional layers. First convolution, we know that there will be 32 filter 5 by 5, and in M scans, M by 5 by 5. And second convolutional layer, it will be using 16 layers, size of each convolutional filter 32 by 3 by 3. So 16 filter, each of them 3 by 3. Size of convolutional filter 32 by 3 by 3. So I think they will not be fully connected. Max pooling layer 3 by 3 spatial pooling area stride of 2. First fully connected layer, it is on the at the end classification side. 10 output neurons. 10 output neuron, the first step, and the second fully connected layer uses softmax. 2 output neurons target exist or absent. Okay, instead softmax, it is using 2 output neurons at the end. I think a target exists or not. Okay, sigmoid could be used because just binary classifications. Anyway, I think based on the configuration or something, they used multiple perception layer as softmax. So it is used for training CNN detector. what is used for training CNN detector. I think in the training stage, I think it's not that just you just apply this to the real data. It does not always work with the, okay, I think what machine learning or deep learning, what's all about, what are all these about? I think initially there is a training phase, right? Depending on the data, feature extraction or different algorithms, it will need to understand, I think probably also how those input maps to output, there will be some training. So then you use it on the testing, whether your training was successful or not. And depending on that, you decide, okay, is this the right approach for this application, or it is performing well? Then you probably will be using on the production, on the real classification or real target detection, those kind of things. So for the training of CNN, it will be using backpropagation and stochastic gradient descent. Backpropagation, I think the recurrent backpropagation is there. What are the different results found by this research paper? I think in the beginning I already discussed this, but still. So CNN detector, it performed better than the CFIR, the constant false alarm rate, when the SNR of target is large, signal to noise ratio is large. Coincidence detection can improve the performance of CNN detector. Coincidence detection can improve the performance of CNN detector. Yeah, I think CNN will perform better when you use that coincidence detections, I think in out of M logic. And in coincidence detection, I think I also mentioned this, the probability of false alarm rate, probability of false alarm, that's kept the same in both cases, CFR and CNN. And it's found that probability of detection of the CNN is better. Okay, I actually have to see whether if you keep PD is higher, then you get better output, or probably I think CNN can also provide better probability of detection. Okay, I believe it's the second one. And the Ryerson softmax that was used, okay, I did not read this specifically in the research paper, I'm just trying to understand. I think, let's say softmax, it gives the probability. It's not completely binary like sigmoid, yes or no. It is just, it will give some probabilistic, okay, 0.6% or 70% or 6% it is target exist. Then depending on the, if we say 60, before 60 target exists, under 60 it doesn't exist. So it will be using probabilities, softmax, and then it will be some algorithms concept for the detection. So the probability of detection is higher in CNN than the CFIR. Okay, hypothesis testing, as I told, near at the end, I might give some information on hypothesis testing and null hypothesis testing. So hypothesis testing, it will be testing various propositions about a data. I think various hypotheses about a data. So example, mean age of Canadian population is 53. It's a multi-step process. Steps can be test null hypothesis, assume the hypothesis is true, alternate hypothesis, hypothesis that will be accepted if the null hypothesis is rejected. So null hypothesis, you assume that is true, and then you form another hypothesis that is alternate hypothesis. If the null hypothesis is rejected, alternate hypothesis will be accepted. Significance level, yeah. So confidence level, I think if they are true for 95% cases. And test statistics. Okay, test statistic, it will also identify if the sample data that we are using, it is consistent with null hypothesis. Critical value, if the test statistics is more extreme than critical value, the null hypothesis is rejected. So decision is made by considering test static and critical value. Okay, references, you will know it. So yeah, here you can see deep neural, recurrent neural networks. Yeah, just because I searched for it, but does that mean that all of the images will be the same thing? So deep feed neural network, if we just want to see what are these. Convolutional, I think it is the different filters. Yeah, if you see the architecture of the research paper, it will look like this. Recurrent neural network, it will be using the backward feed memory, Doppler, yeah, I think radar detector Doppler that is used for the speed, matched filter, yeah, compare known signal with the unknown signal and find out. That's what it is. I can show you the architecture of the CNN as used in the research paper. Okay, this is the structure, that architecture that the research paper has used. So feature extraction, classification, range Doppler spectrum under test, that's the input. Okay, these are the different layers. It's 1, 2, 3, 4, 5, 6, 7, 8. And filtering, you can see, I think each time this thing is getting smaller, and then, okay, what else I can show for this research paper and the study. Okay, I think it looks like I don't have much more to share. Okay,